All right. So as I said, Enhui is part of also part of our team. Enhui it's been part of the team for all the CODESYS development, and he's also the expert on this topic. So what I'm going to do is I'm going to give you a little bit of introduction on the FESTO company. FESTO is a global company. I'm part of the customer solutions in North America, as I said. So in North America, there is a little bit about our footprint. It starts from multiple locations where we have customer solutions engineers, support specialists, production technicians, and many other people that is always behind the scenes making things happen. We're about 475 engineers, production and logistics in North America. And then we also have a larger footprint globally. This is what we have in our global footprint. So 60 plus countries worldwide, 250 sites in 176 countries, and also 20,000 plus employees. We have 22 facilities where we produce, in some cases, very basic components, cables, tubing, pneumatic fittings and stuff, and other production facilities where we produce controllers, PLCs, of course, with CODESYS embedded in, servo drives, in general, motion control, remote I/O modules, and also valve terminals. And also we have 10 logistics centers where we distribute things all around the world. Now, let's talk about the automation solutions for the industry, which is what we currently offer. Starting from the left-hand side, where we have the CODESYS software, and we integrate the software directly in our embedded controllers. So we have from basic CPX ePLCs up to IPCs now being released recently. All of them are running with the CODESYS into it, 32 bits and also 64 bits. On the right-hand side, we have electrical connectivity. So we have servo drives and motion control, which is all tied together to what I'm going to show you later on. And also on the mechanical side, we also have a standard linear actuators. Some of them are more complex, more specified for some specific industries. So we do have a large portfolio. And what we're trying to do here with this presentation is to show you that FESTO, because we have so many products everywhere, we want to make sure that everything connects together properly from the mechanical, but also from the controls point of view and the software. And this is what I'm going to show you in a minute. Now, let's dive into what we call the FESTO motion control platform. The FESTO motion control platform is basically an ecosystem that we've been putting together. This ecosystem is basically a combination of multiple type of technologies. So for standard pick and place operations, where you have in your industry just moving things from point A to point B, soft motion, CAMI, more complex applications, sometimes robotic, sometimes sub-motion for gluing applications, and also palletizing, CNC. All these combined, it's what CODESYS it's helping us. CODESYS is giving us that opportunity to connect from the mechanical components of FESTO up to a sensor level, and also up to the controls and the software development. Now, when it comes to mechanics, FESTO has a large portfolio that is already well established in the market. We have a very good quality products that without going too far, what I want to mention is that the mechanical pieces of FESTO all connects together. So all the servo drives connect directly with the mechanics, with the gears, with all the belts and whistles. So basically all the mechanical pieces fits very nicely. But now when it comes to controls, we need something that can take care of that and make it run it fast. If you remember, when PLC Open started a long time ago, this was the kind of a footprint that we have to follow every time we develop an application with motion control. So when you have like a mechanical pieces like FESTO portfolio, when we have some mechanical pieces and we have to start running it with motion like servo motors and stuff, we have to go through all this machine state and understand and start basically from scratch, like developing the software, basically creating the function blocks, MC move, MC halt, MC, all the MCs, all coming from PLC Open. So what we wanted to do is we want to put all these together and make it simpler for the customer. So people that are not necessarily very familiar with all these infrastructure behind the scenes for all the PLC motion control, they can still be part of it and they can still develop things without necessarily being scared. Because once you see this as your path, that's something that you have to follow in order to make it happen, it's extremely complex. And if you don't do it right, you're going to end up troubleshooting. You're going to end up like handling a lot of code, maybe without a reason. So the whole point for this is really to, what I'm going to show you is to develop a library that can take care of all this and put it as a one single entry point where you can control all this without necessarily knowing all the details. So, of course, when you are developing an application, a library, you always have to look at from the basic, which is, the uniaxial motion, synchronous motion, and interpolation. And you have to combine all those function blocks into a motion library. And then from the motion library, you have to start managing different situations, power, status, faults, and you have to control properly every single state of your library. Otherwise, it becomes, your function block. Otherwise, it becomes very complex and hard to manage. So in a typical scenario, the motion control library will take care of all of this. Of course, from the left-hand side, you have an engineering and library information. In the middle, you have the variables and instructions. And then on the right-hand side, you have the function blocks and how you handle different function blocks for different situations. So what we tried to do with the FESTO positioning basic library, which is what we're going to be talking about here, is we want to act as a simplified bridge between the CODESYS infrastructure and also electromechanical systems from FESTO. And this is exactly what the positioning basic library is doing for us. Is basically hiding all these different blocks and different connections and make it a nice visual, entry point where you have everything right in front of you and you can just select and pick and choose whatever you like. You don't have to start developing code from scratch. The library is really taking care of like probably 70% or 80% of the standard Cartesian applications. And then the rest is really customized based on the application. Some of the key points of our FESTO position basic library is that you can reuse function blocks still in the backend. You can still, in the CODESYS interface, you can still reuse function blocks for all your motion control application. For example, sometimes you have synchronized motion that you want to run with the PLC open, utilizing our library. You can still run synchronized motion, but also you can run standard simplified single axis motion from a point-to-point application. So the library still allows you to control multiple other areas outside of your standard synchronized motion control. It also includes all the data types and drivers that that could be for some specific needs you may have. Because it is used all the PLC open standard function blocks, is going to give you still the familiarity that you could have if you're expert. You can still get deeper in the code and then navigate through different scenarios, different bits and bytes, because you still have access to that. So if you think about the library that we are currently having here, the front end is for somebody that is not necessarily expert in motion control, but the back end gives you the possibility to, when you're an expert, you can still do tons of things with it. Now, when it comes to developing applications, as I said, the library itself gives you 80% of the entire coding, and you don't have to start from scratch. So it takes you to the point where you can still start controlling servo motors around, and the rest is really based on your application. And now when it comes to the additional control layer, we developed something called FESTO Motion Control Package, which is an additional layer that now it connects all the external environment. For example, an external PLC that wants to communicate with your gantry system or your electromechanical system. This controller will be allowed to communicate using a standardized functional block and also a standardized mapping structure. So because we use standard protocols, it's easy for us to switch between Profinet, Ethernet IP, maybe OPC UA, or maybe Modbus TCP. The structure that we developed across this library is very useful because you don't have to necessarily use this like typical brands. For example, people will go with Rockwell or Siemens. You can still use other brands, for example, Omron or Delta or other PLC in the market, is still maintaining the standard field bus technology that you want or you prefer to use. Now, in a nutshell, basically, the library allow us to simplify the soft motion and G-code integration. It allows you control simple axis, but also multi-axis systems. You can run up to 12 or 16 servo drives out of one single motion controller, and you can separate in multiple groups. So this is one of the key points here. You can control 3 different groups of kinematics, and then every group of kinematics will have 4 servo drives. So it really expands, and it's not just one controller connected with one mechanical system. It's actually one controller with multiple mechanical systems. It's a unified interpolator because now it helps you to understand all the interpolation without necessarily knowing all the bits and bytes. And you don't have to necessarily be an expert in order to be interpolation, because it takes care of all the synchronization. It takes care of the kinematics type, for example. In some applications, you might want to use an H or a T gantry. If you're not familiar with H and T, I can give you more information once we get into the Q&A. But basically, an H and a T gantry is mostly like the most complex scenario when it comes to Cartesian systems. And by using this function, this library, it will allow you to do that in a very simple way. All the homing routine and motion commands can also be part of this in a simple way. Sometimes when you're using PLC open function blocks and you're coding everything by yourself, you're going to end up having some challenges. For example, when it comes to homing, homing is very specific based on every brand. So every company will handle the homing structure the way they like. So, for example, FESTO can utilize any type of homing, and with this library, we can actually home H and T gantries in a very simple way. So you don't have to worry about, moving the axis in one way and performing different situations. It's really one push button, you hit and it goes, and that's it. It's super simple. Now, when it comes to CNC integration, because CODESYS has a CNC interpreter, so you will be allowed to use standard CNC and G-code functions. So that will help you to develop a particular path, for example, for gluing application, things like that. And then the visualization is extremely helpful. When it comes to visualization, as was presented by LaserX and others previously, the visualization in CODESYS is extremely powerful, and you can develop tons of things. You can start from basic push buttons, but you can all get it up to a super complex HMIs with a lot of information. So I'm going to show you a little bit of what we did, and we try to standardize the libraries and also the visualization based on FESTO's global, let's say, color and things like that. As I saw earlier with the guys from FANUC, they also developed their HMI using, the yellow color and very, corporate. And this is the nice thing about the CODESYS web visualization and visualization in general, is that you can accommodate and arrange your visualization any way you like. So this visualization that comes with the library, it's also extremely very well done, because you have all the little things that you want to take control from a single entry point. And the good thing about that is the visualization runs the same way on your computer and also on a web browser, on a tablet, or any other device. Now, this is the general overview to what I'm going to be showing you today. From the left-hand side is when it comes to communication. CODESYS really helps you to communicate with multiple brands and multiple protocols, which is key these days. From Ethernet IP, Profinet, OPC UA, and Modbus, which are the most common ones, but you can also expand to other type of protocols as long as you can pay the license, or maybe the controller has already that part of the hardware. Now, at the bottom, you have here in the controller, we have the EtherCAD master. So FESTO globally is now using master on EtherCAD. So basically, all of our products are fully embedded into EtherCAD communication protocol, and we run everything. Run from valve terminals, standard information through the valve terminal, up to full synchronized motion control, everything through the EtherCAD network. And then on the right-hand side, you can see there are 3 different Cartesian kinematic systems. On top, there is something we call a linear Cartesian system, which comes with 2 servo drives, so you can perform left and right, up and down. The one in the middle is called a 3D gantry, which it can perform 3 or up to 4 different movements. And then the one at the bottom, it's a complex kinematic system, which is called we call the F plus B or FESTO Positioning Basic Library. I'm going to give you more information later. And then on the left-hand side, you see the function block that we developed for Rockwell. This function block is being developed for Rockwell is because in North America, this is the most common platform, but we also have Siemens, and we can develop for any other platform. And if you are familiar with your own device, you can also develop this as long as you follow the standard mapping structure that we put together. And then, of course, the visualization is extremely important. So you can use the visualization in our typical teach pendant, your own computer, or even to a tablet. This particular automation platform is called the CPXE, which is a modular system. The one on the left-hand side is the main processor, and then you can start adding slices based on your application. So input, outputs, counter, IO link master, things like that. Now, this is the general footprint when it comes to multi-kinematics. Multi-kinematics is a key factor here because CODESYS allow us to control multiple gantries in a groups, but also it will allow us to communicate upstream. So from a single main PLC, you can control different gantries. All of them are fully isolated. So for example, the one in the left, you can use it for pick and place, maybe taking bottle of shampoo from a conveyor and placing into a box. The one in the middle, because it's a 3D gantry, you could perform a standard CNC path or G-code or even gluing dispensing applications. And the one on the right-hand side is a standard linear Cartesian system. So you can use it for pick and place or maybe just pushing things into a box. I don't know, many other applications that you can use for this. Or in some cases, because this is a nice thing about CODESYS as well, that you can virtualize the servos. So you may end up using only one single kinematic. So for your application, you could run one single gantry solution, which is the one on the left, kinematics 1, and the second and third could be just configured as a virtual environment. So you don't have to necessarily use it. It's going to be there when you need it, but otherwise it will run on a physical, real system. Now, this is the typical screen that you will end up when you start using this library. I will give you more information in a minute, but basically this library will give you all the little push buttons and entry points where you can set up your gantry system from your web browser directly. So you don't have to develop necessarily code in order to run a standard pick and place solution, for example. So this is when it comes to Rockwell integration, as I mentioned earlier, Ethernet IP for pick and place. This one is for dispensing applications. For example, following a specific velocity for path following. So you can configure the velocity and you can just run. So the gantry will automatically adapt the acceleration on the corners and things like that. So it will always maintain the same speed all across the path. And this is all because of the CNC editor that is part of the CODESYS solution. This is basically when it comes to software, that's what I wanted to show you. Now, when it comes to mechanics, FESTO also offers a control box that basically takes the servo drives, the controller, the PLC, and also the rest of the mechanics and put it together as a one single package. So When it comes to control box, this is what we also offer in the market. And this is because, and thanks to CODESYS that runs into it, it will help us to expand the whole portfolio, because now the controller can take care of a lot of automation tasks directly inside the control box, keeping still the multi-kinematic system as we like to use. So for example, here on the left-hand side, you have 2 servo drives running a linear system and another 2 servo drives running a T-gantry. So from one single box, you can control 2 Cartesian systems. So imagine you are controlling 2 6-axis robots from one single box. That's exactly what's doing here. And this is what we typically deliver to the market. The Cartesian system, the control box with CODESYS embedded into it in the majority of the cases. In some cases, people don't want to use the CODESYS controller, but if they do, then we still have it. And then the rest is coming as a one single package. This is a typical application that we came across. Rockwell Automation controlling our FESTO PLC, and then the FESTO PLC performing advanced kinematic systems. For example, if you want to run an H gantry, you cannot run this type of gantry with just 2 servo drives. You have to combine, mathematically, you have to combine everything. So that's one of the key advantages of using CODESYS. This is another solution that also is part of Siemens, is running Profinet, the same type of controller, but then now is running a very large gantry solution for a pick and place. And one of the advantages is because we run an EtherCAT, I actually found this nice stitch pendant that is kind of the typical CNC pendant that you can just move like a wheel and you have some basic push buttons. That is actually an EtherCAT device that will be was actually fully integrated into the standard gantry control. So from there, you don't need a full teach pendant. You actually just need this basic pendant to start jogging the axis and things like that. So, and because it runs on EtherCAT, the integration was extremely nice. All the code is in our GitHub. If you're interested, everything is in there. We can share the link later. Here you're going to see the manuals. You're going to see the code for the Allen Bradley platform and the mapping instructor, and also the CODESYS package. That's for now for the presentation. I'm going to give you 5 minutes on our CODESYS visualization and CODESYS simulation. So this is the project that you will get when you download it from the GitHub. I'm sorry, I'm just gonna, no, it's fine. So what I'm gonna show you here is this project that is in CODESYS is running a lot of things. It's running, first of all, the Ethernet IP site, which is here. Through the Ethernet IP, we're mapping all this data for in and out. So this is basically the host connectivity. From here, you can connect to a ROM PLC through Ethernet IP or a Rockwell PLC or any other. But you can also switch this to Profinet, and then you're going to end up with the same type of mapping, and then you can communicate with other type of PLCs, such Siemens. Here on the left-hand side at the bottom, you're going to see something called a soft motion general axis pool. What we've done is this library runs everything on virtual servos, but also it could run physical real servos. So when you want to run maybe some testing applications, something that you want to quickly evaluate, you can use a virtual servo drives. But also it runs physical real servo drives. For example, here I just configure 2 FESTO servo drives that will allow me to communicate via EtherCAT and utilize all the soft motion. And then the library itself, I'm just going to get into the visualization. This visualization will be available in any web browser, as I said. And this visualization, I can run it directly from my controller. Let me just move this a little bit here because I'm not seeing the... I'm just going to download it into my virtual environment. All right. So from here, I have my system running. Just going to move a little bit because I can't see the whole. This is still loading. Just give me a second. So right now, I don't have the physical PLC with me. So I can still run the library, I can still run servos, I can do all my testing, I can run some routines, maybe do some coding, which is nice. It's nice to have that virtualization, which is extremely powerful in CODESYS. And then here I have my system running. So if I want to, for example, run the code right now, sorry, I'm just going to move this because it doesn't show me. Okay, now I have my system running. So the first thing I'm going to show you is this push button at the bottom. It's basically isolating all the host connectivity from upstream. So if this is a real controller running kinematics, as soon as I press the button here, I will take control of the entire environment. So from here, I can switch, first of all, between 3 different kinematics. So I have in this kinematic, I have it configured with 4 servo drives. This one is configured with also 4 servo drives, and the first one is configured with 2 servo drives. So right now I'm running 3 different kinematics, basically 10 servos all together from one single entry point. And then from here, I can just simulate like enabling my system. I can home. This is a T gantry. The way I configure is a T gantry. So I can home from here. I can also start jogging my device. There is a nice tool here that is called the override. So here with this slider, I can adjust the velocity of my T gantry. Then I can start jogging. I can also change the velocity for my T gantry. Let me just put here a number. So I can increase the velocity now. I can also move my mechanics a little bit up and down, left and right. Okay, I can also do some stepping mode. The stepping mode is basically telling move this amount, this step width, for example, 20 millimeters. And I can just press and it's gonna go by 20s, okay? And then I can also do something called point to point. So from here, I can just enter the destination I like, the velocity, and then move it. So now the system is running in 2 Cartesian space. Okay, so all this, what you see here, all the simulation can be done with a real system in a matter of a click. In a matter of a click, you can just set that up. Instead of virtual, you can switch to real, and then you can start running your Cartesian system. Chris, I think I have only 30 minutes. So if that's okay, I think I'm going to stop at this point.
You don't have to stop. We are free in time. If you need more, please take your time.
Okay, then I can stop. I can have 5 minutes more, and then I can
Absolutely.
show you a little bit more here. So this virtual environment here, for example, I can run CNC mode, or I can run external CNC mode. So if you remember, CODESYS has already a CNC interface. So I'm going to search for my CNCs. Just give me a second. I have all these CNCs already loaded in. So for example, I can just take this entire G code and run it with my mechanical system. And how I do that, I just have to go into my visualization and select which CNC I want to move. From here, I can also call for an external CNC. Just give me a second. It's kind of waiting for, okay, here. I can select an external CNC. So I can go and search for a CNC file. If you have maybe a DXF that you want to convert it externally and you want to bring it into here, you can also import it. Also, when it comes to configuration, for example, if you have instead of a T gantry, tomorrow you're going to have a 3D gantry, like a 3-axis gantry. So you can go into the configuration mode. And then by logging into here, you can go and select the kinematic you like. So I can select here an X and Y system, which is a typical Cartesian solution, or you can select an H gantry. So by selecting this, now you're switching the entire kinematics inside the library, and it will allow you to switch automatically from 2 servo motors synchronized now to up to 3 or 4 servos. You can also select the amount of servo drives you want to use and the orientation. This is very typical in Cartesian if you're familiar with. You can select also the type of dynamics you like. Some people, for example, they don't want to run very fast in one single axis, but they want to run the other one the maximum they can. So you can select all that data here. And also the type of homing. If you're familiar with electromechanical systems, you always have to select what type of homing you like. If you like mechanical stop, if you like a sensor, if you like a stop and sensor, all those typical PLC open MC home type of homing methods. So you can select that too here. For example, you can select if you want to use a limit switch, or if you want to use negative limit switch or positive limit switch. All that is established directly in the library. So you don't have to really go deep in the code in order to make your system work. But let's say for now, I don't want to touch this kinematic system. I'm going to switch to the second kinematic. Now I have my 4 axis ready to go. I can just go here, enable my system, and I'm going to go into the jogging. So here I have an X and Y gantry. So I can start jogging. Let me just increase the velocity. So I can start increasing now the jogging. I can jog left and right, up and down. With my mechanical system, I can also rotate if I want to rotate, because I have 4 servos in this case. And I can also switch my third kinematic, which is still running in the background. And now I can enable my system and also go again to the jogging. This one is also an X and Y with 4 servos. So I can start jogging. As you can see, they are fully independent, fully isolated. So now I can start jogging this and this. So as you can see now, I'm running 3 different kinematics, all connected to one single PLC controller. And I also have host connectivity, in this particular case, through Ethernet IP. Chris, I think I'm good for now. I will be looking forward for the questions.